In this video, we are going to study the rational function 2x minus 4 over x plus 2. We are going to find its domain, x and y intercept, the asymptotes, and then make a table of sign and then sketch it. So let's start with domain. Now the domain is a set of all x values, of all values of x, that will make the function, the y value of the function, real. So here we have a ratio of two polynomials. So the polynomial in the denominator cannot be 0 because division by 0 is not allowed. And that gives me x not equal to -2. So this is the domain, and we may write it using ranges or intervals. Minus infinity to -2, union -2 to plus infinity. So it's all real numbers except -2. B, x-intercept. Now the x-intercept is the intersection of the graph with the x-axis, and therefore on the x-axis y equal to 0. So what we do, we put y equal to 0 into our function here, this side equal to 0. So 2x minus 4 over x plus 2 equal to 0. Now this gives me a numerator equal to 0, and when I solve this, it gives me x equal to 2. This is the x-intercept. Now the y-intercept is the intersection of the graph with the y-axis. On the y-axis, the x is equal to 0. So what we do is we go again to our function and we set x equal to 0 into the equation. So y equal 2 times x minus 4 divided by x 0 plus 2. When we simplify, this gives me y equal -2, and this is the y-intercept. Now let's find the asymptote. Now first, let's find the vertical asymptote. The vertical asymptote is found by solving the denominator x plus 2 equal to 0. So that will give me x equal -2, and this is the equation of the vertical asymptote, which is the vertical line, x equal -2. Now the horizontal asymptote. Now I'm saying that there is a horizontal asymptote because I can see that the degree of the numerator and the degree of the denominator are both equal to 1. So for x very large, in the numerator 2x will dominate, will have main value. And then in the numerator, it's the x that will dominate. Now when x is very small, remember when we say very small, it still has a very large absolute value. So again, it's 2x that will dominate in the numerator and 2x will dominate in the denominator. So in both cases, it's the 2x over x term that will dominate, and then this will simplify to 2. So our horizontal asymptote, it's a horizontal line with equation y equal to 2. HA for the horizontal asymptote and VA for vertical asymptote. Now, are there any intersection between the horizontal asymptote and the graph? Let's see. Now, to find any intersection, we take the equation of the horizontal asymptote. We take the equation of the function 2x minus 4 over x plus 2. Now, we put them equal, and then we look for any intersection. X plus 2, cross product, that will give me 2x plus 4 over equal to 2x minus 4. So these 2x, both sides will go, and then I have 4 equal to -4. No. So no intersection between the graph of the function and the horizontal asymptote. Now, of course, the vertical asymptote cannot cut the graph because it's undefined at that point of the vertical asymptote. In part D, we are going to study the sign of y equal to x minus 4 over x plus 2 as x changes. Now, we do this exactly as we are solving a rational inequality to x minus 4 over x plus 2. So first we start with the numerator, and with the numerator to x minus 4 is bigger than 0 when x is bigger than 2. Solving this gives me this. Now let's go to the denominator. X plus 2 is positive, and then when I solve, that gives me x bigger than negative 2. Now here on the table of sign, what do we put? We put first the numerator, and then the denominator, 2, and then y, the function, which is the ratio. The ratio. Good. Here, what do we put? We put the zeros, the values that makes the numerator equal to 0, and the value that makes the denominator equal to 0. Now, the value that makes this 0 is x equal to 2. And the value that makes this equal to 0, it's x equal minus 2. We put minus 2 on the left, is the smallest, and then the 2 here. And then we start. Now, 2x minus 4 is positive when x is bigger than 2. Here is 2. When x is bigger than 2, you go to the right. This is positive. So we put the plus here. Of course, less than 2, it will be negative. Same thing, x plus 2, the denominator will be positive when x is bigger than negative 2. Negative 2 is here. When x is bigger, you go to the right. Quantity x plus 2 is positive. And here it's negative. Now y. Y is the ratio of the two. So the ratio of two negative number gives you positive. The ratio of negative over positive, negative, and then positive here. Now that we have the table of sign, the x and y intercept, the asymptote, we are going to sketch the graph of the function now. Here, of course, we have negative infinity here, and plus infinity here. Now, first, we put the asymptote. This is the vertical asymptote, and its equation, x equal to 2. It's a vertical line. This is the horizontal asymptote, y equal to 2. Horizontal asymptote. Now the x-intercept, x equal to 2, this is the point. This is the x-intercept, it's the x-axis. So it's on the x-axis, and therefore we expect the graph of the function to get the x-axis at this point. The y-intercept is equal to minus 2, so it's this point here. Good. Now let's start. From minus infinity to minus 2, so from the left to minus 2, the vertical asymptote, the graph is going to be positive. Y is positive. So it's above the y-axis. And we start from here, because remember the graph is close to the horizontal asymptote, and then we go up to the vertical asymptote without cutting it, of course. Next, from minus 2 to 2, from the vertical asymptote to 2, which is the x-intercept, the graph is negative. That means, the y is negative. That means the graph is below the x-axis, the x-axis. So we start from the vertical asymptote. The graph is close, and then it cut the x-intercept. So it's here. It's negative. Now from 2 to plus infinity, so from the x-intercept to plus infinity, the graph is going to be above the x-axis, and it will stay close to the horizontal asymptote. So this is the graph. Now, so with this, we have finished finding all the information and sketching the given function.